In this video, we will learn how to find the length of a diagonal line segment. Now, what if a line segment is not horizontal or vertical like this one? We call this a diagonal line segment. How then can we find the length of such line segments? We will now learn how to find the length of this diagonal line segment by first constructing a right-angled triangle. First, let us draw vertical and horizontal lines from the two ends of the line segment. Can you see the right-angled triangle? The hypotenuse is the line segment. The right angle is the point where the vertical and horizontal lines cut. The point has the coordinates of 1, 1. We will next use Pythagoras' theorem to find the length of the diagonal line segment. We can see that the horizontal line is of length 4 units and the vertical line is of length 3 units. Therefore, using Pythagoras' theorem, the length of the diagonal line segment is the square root of 3 square plus 4 square. And by using a calculator, the length of the diagonal line segment is 5 units. Let us try to find the length of another diagonal line segment. Coordinates of the endpoints are -3, -1, and 2, 3. Like in the previous example, we will construct a right-angled triangle from the two endpoints of the line segment. Let us draw a vertical line from one endpoint of the line segment and a horizontal line from the other endpoint of the line segment. We can see that the lines meet at right angles at a point, and the coordinates of this point are 2 and -1. This point is a right angle because the vertical and horizontal lines are perpendicular to each other. Let us now find the length of the horizontal and vertical lines using the coordinates. The length of the horizontal line is 2 minus -3, and this gives us 5 units. The length of the vertical line is 3 minus -1, and this gives us 4 units. Hence, using Pythagoras' theorem, the length of the diagonal line segment is the square root of 4 square plus 5 square, which gives us 6.40 units, correct to 3 significant figures. You'll probably agree with me that it would be rather tedious to always construct a right-angled triangle to find the length of a diagonal line segment. Let us try to generalize a formula to help us find the length of such line segments. Consider this line segment AB with the coordinates of the two endpoints denoted as A, x1, y1, and B, x2, y2. We now draw a vertical line and horizontal line from the two endpoints to form a right-angled triangle. This point, C, is the right angle. The y-coordinate of this point should be y1 because A and C are on the same horizontal line. The x-coordinate of this point should be x2 because B and C are on the same vertical line. Hence, the coordinates of C are x2 and y1. Now, let us focus on finding a formula for the length of this diagonal line segment. Recall that in the previous example, we obtained the length of the horizontal line by taking the difference in the x-coordinates, that is 2, the larger value, minus -3, the smaller value, to give us 5 units. Thus, the length of horizontal line AC can be obtained by taking the difference in the x-coordinates, that is x2, the larger value, minus x1, the smaller value. Similarly, we obtained the length of the vertical line by taking the difference in the y-coordinates, that is 3, the larger value, minus -1, the smaller value, to give us 4 units. Therefore, the length of the vertical line BC can be obtained by taking the difference in the y-coordinates, that is y2, the larger value, minus y1, the smaller value. Using Pythagoras' theorem, the length of a line segment can therefore be written this way. The length is essentially the square root of the square of the difference between the x-coordinates, that is, x2 minus x1 square, plus the square of the difference between the y-coordinates, that is, y2 minus y1 square. Let us take a look at one example where we can apply what we have learnt. A is point 9, -5, and B is point 212. Find the length of AB. It is always good practice to make a quick sketch of the information on a coordinate plane to see how the line segment actually might look like. Now, let us apply the general formula to calculate the length of AB. At this point, we have to ask ourselves which coordinates are x1, x2, y1, and y2. One easy way around this is to label the coordinates as we read them from left to right in the question. For the first set of coordinates, A, 9, -5, we label 9 as x1 and -5 as y1. For the second set of coordinates, B, 2, 12, we label 2 as x2 and 12 as y2. Now, we may apply the formula to find the length of AB. Length AB equal square root of 2 minus 9 square plus 12 minus -5 square. This gives us square root of -7 square plus 17 square, which is square root of 338. Using a calculator, the length AB is 18.4 units correct to 3 significant figures.